In this video, we are going to show you how to become more familiar with your data. No matter what your end goal is, getting to know your data is always a useful first step. It goes without saying that data can get very complicated. A well-designed and friendly programming language like R can help us make sense of this complexity. R has some simple functions that enable us to perform what is known as exploratory data analysis, or EDA. For this series of modules, we will use a dataset called Happy. These data have been downloaded from Kaggle, which, in addition to being a site that hosts machine learning and data science competitions, contains a large repository of interesting and useful datasets. The original dataset was produced by Gallup, who conducted a worldwide poll to determine levels of happiness in different countries. This dataset also contains information like GDP and life expectancy, and so can be used to try to understand what makes people happy. We will begin by using a small subset of the actual dataset. This will be small enough to fit on our screen so that we can clearly see what our code is doing. We will eventually use the whole dataset to illustrate more advanced concepts. For now, our abbreviated dataset will contain just 4 variables. Country_name, which contains the names of the countries. Ladder score, which is the average ladder score for a country. And this is a measure of subjective well-being that ranges from 0, the lowest score, to 10. GDP, which refers to the log-transformed gross domestic product per capita. And finally, social support, which is the average of all the responses to the question, if you were in trouble, do you have relatives or friends you can count on to help you whenever you need them or not? And this score therefore ranges from 0 to 1. Okay, let's now become more familiar with this dataset. To see what our dataset contains, we can simply enter its name, which in this case is Happy. If we look at the output, we see the entire dataset. We can see the names of our variables and their values for each entry. There are a few other details in this output that we will go over soon. We'll continue our EDA by using some simple but useful functions, and we'll begin with dim. Dim is a simple function with a simple output. Dim stands for dimensions. The code is simple. We type dim and enter the name of the dataset within the parentheses. If we look at the output, we can see that we just get 2 numbers. Since this is a rectangular dataset, it has rows and columns. And dim just gives you the number of rows, which is 5, and the number of columns, which is 4. One point worth mentioning here is that these datasets are, quote, tidy, meaning that each row corresponds to a unique observation, and each column corresponds to a particular variable or feature. So whenever you see rows, think observations, and whenever you see columns, think variables. Tidy datasets are both a nice way to organize your data, and they make it easier to do things like EDA or plotting. So dim is useful but limited. A more comprehensive function is called glimpse. Let's apply glimpse to our dataset, which we in this case can also refer to as our data frame, and I'll be using those 2 terms interchangeably. Once again, the code is simple and looks just like dim. When we run glimpse, we can see that it too shows us how many rows and columns our data frame has. And the output clearly tells us which number refers to row and which to columns. Whereas in the case of dim, we need to remember that the first number of the output refers to rows and the second to columns. Importantly, glimpse also shows you what the variables in your dataset are, the first few entries for each variable, and information on each variable's data type. There are some basic data types in R worth knowing about. The first is the character data type, which could be a name or a letter or anything in quotes. The second is numeric, which can be whole numbers or numbers with decimal points. Then there's integer, which refers to a whole number. And the way to tell R that a number is an integer is by placing a capital L at the end of a whole number, So when you see a number with an L after it, you know that it's an integer. There's a logical data type, which can take on a true or false value. And there's the more exotic raw data type that we won't be covering. You will also come across what's known as a double or DBL. And this simply refers to a number with a decimal point. One final thing worth knowing about is the factor, which refers to a collection of ordered character variables. So if you, for example, think of a list of names and you had no other information about the names, they would likely just be a collection of names with no particular order. However, when you think of the months of a year, then order matters. So we would need to tell R what the order of months is, and the factor allows us to do that. You have been previously introduced to this concept known as the pipe, which is this percentage greater than percentage symbol. Might at first seem a little strange, but once you get used to it, it makes coding very intuitive. Recall that whenever you see the symbol, always think and then. Let's walk through an example of how to use this operator. We begin with our dataset or data frame, happy, and then, by using the select function, you select 2 columns from happy, and then, you only keep those rows that match a certain condition. We do this by using the filter function, and we will be covering both the select and filter functions later on. And this is the output of this code. So, why do this? The alternative to chaining lines of code using the pipe operator is to nest everything so that it all fits in one line. This is fine and will give you the same output, but it's difficult to read and write and is so more prone to error. The pipe operator works especially well with functions from a package known as dplyr, which is one of the workhorse packages of the tidyverse. The dplyr package contains functions that enable you to do lots of useful things with your data, like choose specific columns and rows. There are dplyr functions that you can use to generate new variables and produce summary statistics. While there are numerous dplyr functions, we will focus on a few important ones, like select, filter, arrange, mutate, summarize, and group by. And there you go. You now know how to perform some basic EDA in R.